Hi, this is Chuck Benedict. I'm a mentor for Team 997 Spartan Robotics in Corvallis, Oregon. This is the next video in my series of vision processing, and I thought I would take a little time to describe the performance I was seeing between running the ball finding vision set of pipelines that I'm building for our BunnyBot project, between running it on Windows and running it on the Raspberry Pi, because I've found some pretty stark differences and thought I would report what I found, how I found it, and I have some ideas on what I'm going to do to make some changes. So I thought I'd put those out there as well. First thing I wanted to show you is that there's a um, profiling capability that's built into Java that's pretty interesting. It's been in Java since version 4 or 5, I guess. It was undocumented at first, but now it's fully supported. And what you do when you run your Java application is you pass this flag here, hyphen agent lib colon hprof, and then you can give hprof some different parameters. The parameter that I've got in here is CPU and samples. And what this does is this randomly goes and looks at the threads that are running and takes a snapshot of the threads and how often it sees individual method calls of those threads on the stack, and it basically sums up that time for you. It's not completely precise. It doesn't give you like millisecond related timings, but it gives you a pretty good idea of what's on the call stack over time. So what I thought I would bring up here to show you, on this side of the screen, on the left-hand side, this is what the Windows profile looks like. And on the right-hand side of the screen, this is what the Raspberry Pi profile looks like. And just so you know, I'm seeing pretty significant performance lags on the Pi. I'm not going to show them in the video directly, but on the Windows side, I'm with the project that you can download on the in the comments section. I'm seeing anywhere between 25 to 30 frames a second almost on Windows for video with the image processing, which is really good. On the Raspberry Pi, I'm seeing somewhere in the neighborhood of 2 to 4 frames a second, so almost 10 times slower, which is kind of surprising to me. I expected the Raspberry Pi to be slower, but I really didn't expect it to be really an order of magnitude slower. But there's not a lot of good information on the internet as far as I can tell. There are people that say that it's slower, but I haven't really seen a lot of good actual real world timings between Windows and the Pi. So having said all that, right hand side's the Pi, left hand side's Windows. First thing that you really notice is that the feature detect calls are the ones that are taking a lot of time, and it's not surprising because detecting blobs on frames is what I would expect to take the most amount of time. And in each case, it is the most time-consuming method call. But what's interesting is that the most frequented call is grabbing the frame from the camera server, is the one that's taking the most amount of time, followed then by the two feature detector calls. Over on the Pi side, what you can see is that the feature detector calls are by far taking the most amount of time, taking over 50% of the amount of time, followed then by the blur function calls. And then, because each one of those are taking 13%, then followed by the grabbing of the frames from the camera, which is taking, in this case, it's taking 12.8%. But as you can see on the Windows side, that actually takes 38%. And the way that I would explain this is that on the Windows side, what's bound, the program is bound by I/O. So it's spending most of its time trying to grab the frames off of the network, and then the rest of the time is devoted to actually processing those frames. On the other hand, on the Pi side, the Pi is bound by image processing functions, and then subsequently by I/O, getting them off of the camera. So the unfortunate thing is this doesn't really give you a good sense of by what order of magnitude these things are off by. But this being able to get these timings is very, very simple because, as I mentioned, you just stick it on the command line, you run it, and then you hit Control C to interrupt your program, and it spits out a file called java.hprof.txt in your bin directory, and then you basically get this for free. So what I did is in later versions of the project, I'll probably label this 004 in case you're following along. I created a class called profiler.java, and I put start and stop calls around each one of the image profiling functions in the application, and I was able to get millisecond timings on average for a run on the Raspberry Pi versus a run on Windows. And so this actually conforms to what I was seeing on the by actually running the application. So on the Pi side, I'm seeing roughly 408 milliseconds, 400 milliseconds, let's call it, to do a complete image pipeline. And on the Windows side, I was seeing 54 milliseconds. Pretty surprising, almost order of magnitude, call it 8 to 9 times, which corresponds more or less to what I'm seeing frame per second wise. So what this is really telling me is that opencv, which is the image processing library we're using, is very inefficient on the Raspberry Pi. Now, the opencv version that I'm getting is the version that First has compiled and is sitting on First's Maven site. I believe it's version 3.10 of opencv, and I'm not sure what compile flags First may have used to build that library, because as I understand it, there are some optimizations that you can do to opencv on the ARM platform, which is what a Raspberry Pi is, that helps deal with floating point arithmetic, which is challenged on the Raspberry Pi. In fact, it doesn't really do floating point arithmetic. So I think there are some things that probably can be done to make opencv run faster. Some of the things that I've read seem to suggest if you do the two optimizations that are online by just compiling it with these flags, a couple of flags set, you can get a 30% performance improvement. Obviously, that's not going to get you, 8 or 9x in performance improvement. So what this is really telling me is that the Pi is not particularly good at vision processing. And also 2 to 3 frames per second for our applications not going to be fast enough, although in some applications it might be fine. It depends on what you're going to be using it for. For what we're going to be using it for, it's probably not good enough. But there are some things that we can do that I'm going to try, and I'll probably record another video after I do it. I'm really doing 2 image pipelines, sort of one after the other, one for blue balls and one for red balls. So one thing that can be done is I can put those 2 pipelines in separate threads and have the Raspberry Pi chew on those simultaneously. The other thing that I noticed, which I thought was interesting, is the I/O bound component. I could spin off another thread that does nothing but grab frames off the camera and tease those images up such that they're ready to be passed into the image pipelines, meaning that the frames will always be there ready to be processed by the pipelines. Because that does seem to be a significant amount of wait time, because I have them serially being executed in the application. So I'm expecting that both those 2 things, I could get a 50% performance improvement by processing the threads together, and potentially another 30% performance improvement, give or take, by teeing up the frames off the camera in another thread. That might actually be sufficient enough. I'm figuring I need 10 frames per second or so. Maybe that might actually get us there, because having to compile opencv on the Raspberry Pi is a pretty painful process. It takes, I've read it can take hours and hours to do that. Then, of course, you have to put the binary up on Maven somewhere to have it available for download. So that's kind of a hassle that I don't really want to do. So I thought all this was useful information. You might find it useful in your own situation. And so I am going to be doing as I mentioned, and I will report back with my results. Thanks for watching.